Okay, we're going to talk about correlation and regression wisdom. So we discussed this some in class, but just to kind of recap, doesn't matter which variable is x and which is y. It does not matter for r in the computation of r, which is, of course, your correlation coefficient. It does matter for the least squares regression line. So yes, for the least squares regression line, you will get a different model because you're making a different prediction. Okay, so yes, for the least squares regression line, you will get a different model, and that is because you are making a different prediction. Now, one of the things to talk about is sometimes it is clear which one should be x and which one should be y. And it's obvious that one is the explanatory and one is the response variable. So if it is clear, be sure to use the right variables. So use your specific x and y for clear, explanatory / response situations. So an example of that would be on the quiz that we took. We had I think it was the weight of the car and the fuel efficiency of the car, and most definitely the weight was explanatory and the fuel efficiency was the response. All right, so which of the following has the highest correlation? So some of you may look at this and say, oh, well, maybe this one because there is a linear pattern there. You probably wouldn't think it'd be that one. Might be this one. You have the one outlier, though. Probably not this one. But the bottom line is, believe it or not, these all have the same correlation coefficient. So these all have the same R. So what are you going to do? You always plot your data. And when I say that, I just mean a scatter plot before interpreting R. Okay, remember R is only to describe a linear relationship between two quantitative variables. Okay, so these all have the same R. Always, always plot your data before interpreting R. Only use R to describe a linear relationship. Okay, so how do outliers affect correlation? The least squares regression line and standard deviation of the residual. And are all outliers influential? No. Some are not. Some do not impact the model that much. And I'm going to point out, so I have a little note over here on the side, a data point in the overall pattern is not considered an outlier. So a data point in the overall pattern is not considered an outlier. So just very quickly, I'll do a little sketch here. So I'll say I have some data, it looks like this, and then I have this point over here. This is in the overall path of the rest of the linear relationship. So it would be influential because it would strengthen the model, but it would not be an outlier. So not. And I know initially we called it an outlier just for the sake of naming it at that point in time. Okay, so let's talk about these outliers that are not influential and their impact. and then also the outliers that are influential and their impact on your R, your least squares regression line, and the standard deviation. So outliers that are influential. And I'm just going to kind of abbreviate here. Okay, so we have R, we have S, we have the least squares regression line or the model itself, and then we also have the residual plot. I'll talk about the residuals. If you have an outlier that is not influential, it means it doesn't fit with the overall pattern of the data. However, it's not having a huge impact on the model, maybe because of where it is on the scatter plot. But R will always go down, some at least. S will always go up because you will have a larger residual, and I'll talk about that in just a second. These will be larger. And the least squares regression line will definitely change. Some. You just don't know until you actually run the regression. Model changes slightly. So this would be a scenario when you have an outlier, but it's not really pulling the line to it, so it doesn't have a huge impact on the model itself. But you will have a larger residual, so that will increase your S, because your S is your average, basically the average size of your residuals, and the linear relationship will decrease. Okay? Outliers that are influential will also have an R that goes down, will also have an S that goes up. The model will change significantly. Or it can change significantly. It just depends on how influential it is. And then finally, it will not necessarily have a large residual. Will or may, you just don't really know, not have a large residual. Because if it pulls the model to it, then there's a good chance, for example, and we're going to do in just a second. So say my data looks something like this. And then I have a data point down here. And what would have been a model that, or a line that fit pretty much through the rest of the data, it may pull it down towards it. And probably wouldn't be that close. But then it wouldn't have a very big residual. But it drastically changes the model there. Okay, so let's continue on. I'll go down to the next little section. So here's a scatter plot. And the question is, what effect did the two netbooks that cost $500 have on the equation of the least squares regression line, the correlation, the standard deviation, the residuals, and R squared? So it is going to, I'll do this from the perspective of if I took out the outliers, what it would look like. So without the outliers, the slope would become positive. So it would go something more like this up through here, something to that effect. I'll just sketch that in real quick, but it'd be something like that. So totally change the slope. If you take the outlier, if you take these out, these residuals will be minimized as well as all the residuals over here because the line will fit better. So S will go down. R will go up because the linear relationship will be stronger between the two variables. And then, of course, R squared would have to go up as well. So these are outliers because they're not in the pattern of the rest of the data. And they are also influential because they're impacting the model quite a bit. And then I think this would be roughly the least squares regression line without the outliers. Without outliers. Okay, so we have another brief little section here to go over. This is mainly fill in the blank here. So here's a scatter plot, and we're going to use our DOFs to make sure we can explain it. Showing the relationship between the number of fouls and the number of points scored for NBA players in the 2010-2011 season. Describe the association, first of all. We'll do that down here. And should NBA players commit more fouls if they want to score more points? So we're going to see if there's a causation or cause and effect relationship here. So there appears to be a positive, somewhat curved. You can kind of see it curves up something like this, basically. Moderately strong association. There may be a few outliers that are not part of the overall pattern. No, we do not know if making more fouls causes the player to score more points. There may be other factors such as playing time, aggressiveness, talent, all those things could come into play. Aggressiveness. That impact the number of points scored. Okay, now how do we calculate the equation of the least squares regression line using summary statistics? And this just means either one var stats or you're given the data or you're given the stats. And usually you would have to be given X bar, Y bar, and R to get started on this. So what we're trying to do, it is on the formula sheet. So on the formula sheet. And we have y hat is equal to b sub 0, b naught is sometimes what that's referred to, plus b sub 1 x. And remember, this is just like your a from your regression when you run the least squares regression on your calculator, and this would be your b. But this is what's on the formula sheet. Okay, so this is going to give you the same thing as option 8, or at least it's option 8 for me. It probably is for most of you on calc. Okay, so if you have to write this yourself, and this actually will happen from time to time, the first thing you're going to do is you're going to find, you will find your slope. And it's the formula. It's simply R times the standard deviation of y divided by the standard deviation of x. And you find that, and then you use that and input it second into the equation to find your y-intercept. So find b naught, which is going to be y bar, that's just your average y, minus the slope you just found, and then times x bar. Because remember, the least squares regression line has the point x bar, y bar on it. Is on the least squares regression line. Okay, so that's a two-step process. Now, what happens to the predicted value of y for each increase of 1 unit in x? And this is how we interpret slope every single time. So we will say the predicted y value, but you want to use context. So the predicted y value in context, so whatever it is you're trying to predict, will always go up and that's for a positive slope, or down, and that's for a negative slope, the amount of the slope, or the value of b. So, and then of course this is going to be your b from y hat is equal to a plus bx. So the predicted y value in context of the problem will always go up or down the value of b, and also put it in context as well. And that wraps up the notes for today. Complete number 7 for homework. And then if you want to get ahead, you, of course, move on to homework 8 or 9.